Hi, so I'm Alan Rallings, CEO of Cyclopic, invited by Catapult here this morning to introduce the electric drive system. And I'd just like to open with a short video. Oh yes, just explaining our platform here. You can see that that's an aerodynamic move from the units. The rear wheels there lifting, which would be the back end of a vehicle, of course, and therefore giving you aerodynamic capabilities. There's a parallel parking motion there from the rear wheels that can be applied to all four wheels. Also, there's the roll from left to right, which gives you cornering potentials, high-speed cornering, and electronic suspension. So we can raise and lower the vehicle without hydraulics. It's all totally electronic. It goes into the full parallel parking mode with all wheels facing at 90 degrees to the original, and still get height adjustment with that as well. And moving back into standard drive mode, forwards and backwards. The lifting capability also allows you to put the chassis on the ground, which means that you could have a very low loading point for the vehicle. Therefore, it would be really good for limited mobility use, as shown in this animation. The animation showing you also, because you can go on the ground, you can get better results from induction charging, as you can see from that demonstration, with the battery packs also being very close to that charging unit. And again, just showing you the possibilities for limited mobility use. So that really sums up the ability of our platform that we're developing, and hopefully using AI to have a digital twin to prove out the concept for commercial use. Okay, so to explain the electric drive technology that our company has developed with Innovate UK Smart Grant, and how producing that innovation has now led us to winning a second Innovate UK grant to work with the Cav Lab at the University of Surrey to produce a digital twin simulation platform of the drive system, highlighting the warehouse robot capabilities and logistics potential. Initially, when we began the feasibility study with the University of Surrey, we had to look closely at our CAD and prepare file formats, which included scaling down and remodeling the CAD. Working close to Cav's lab researchers, Bargin Dega and Mustafa Yurim, throughout the process, one task has led to another. For example, leading into renewed CAD for the load chassis variations. The researchers have used their database at the research facility to develop the simulation platform in ROS, to implement the AI algorithm and create a software-defined format in ROS. This process produced a report summary, which has highlighted the sensors needed for the safe and efficient operation of the AMR. In the connection and the concentration of the load sensors, cell sensors, as they are used to determine the weight of the load placed on the drive system that's used to drive the robotic platform, producing unique versatility. Wheel encoders are needed to get precise measurements of the wheel rotations, which can be used for distance calculation and path planning for the advanced autonomy of the vehicle. The inertia measurement unit also assesses linear and angular motion of the AMR platform and movement, optimizing navigation and course correction during its autonomous operation. Radar is also essential
for obstacle detection in the dynamic warehouse environment. Using radio waves, it measures the distance of multiple objects surrounding the AMR to avoid collisions, ensuring safety and precise autonomous navigation. Within the digital twin, we also highlight an RGB-D camera, essential to collect information about the AMR's surroundings. When all this is achieved, the AI system will be capable of identifying the ideal loading spot on the graphic display for the warehouse operators or cobots' convenience. As the development of the digital twin works with the integrated AI and the hardware, it becomes an excellent example of system integration that will provide valuable real-time results. The value of using a digital twin at this stage of our product development is to demonstrate how it is possible to maximize core fulfillment technology and significantly increase overall productivity and efficiency. The digital twin will demonstrate the benefits of the drive system, establishing accuracy and possibilities of speeding up the process within the warehouse operation. The benefit of the digital twin will be to get the facts and figures required for the investment and accelerate our commercial journey as Cyclopic progresses beyond the Innovate UK project. Thank you.
So our first question here, Alan, is to yourself, is big or challenging? How is what you are doing differ? How is what you are doing differ significantly to what retail vacuum robot cleaners are doing? They can even self-generate their own digital twins of their environment using LiDAR and similar, and take location-based actions on the data they gather from their sensors.
Right. Yeah. Well, we think we're working with the digital twin that is being built really to maximize the speed and efficiency of our particular bot in moving equipment around a warehouse environment. So it's really down to the technical speed settings, etc., that to run the motors and adjust the torques, etc., to get the actual maximum out of them. So it's on the engineering side of it really that we're looking at. But yeah, we're very aware of the other software that's around to run within a warehousing environment and the safety, etc., that goes with all that. So mainly based, say, looking at what we can maximize out of the hardware, really.
And a question, Alan, for you is, the real world doesn't always give the outcomes one expects. Given you're working on autonomous technology, what steps are you taking to de-risk error cases in your AI-powered robots?
Yeah, well, the software regarding the safety of these units now is becoming more and more sophisticated, and the sensory systems also have moved on a huge amount. And so obviously we'll be looking to the latest technology we can implement with the system that we're trying to design. And hopefully we'll cover where we're going with what's already been learned about the problems within the warehousing environment, which has been a lot more than been talked about, I think.